This video is a beginner's guide to what a resistor is and basically what it does and how to read the resistor colour code. That seems to confuse everyone. It certainly confused me when I first came across it. So let's have a look at some resistors. We've got a resistor here. We'll turn it around that way so the colour code's easier to read. That's red, red, black, and I can tell you that's 22 ohms. But we'll be going through the resistor colour code properly later. This is an old high wattage type. That's from a 1970s TV set actually. But the sort of resistor you're most likely to come across are these sort of 1/8 of a watt resistors, which you'll use if you're experimenting on a breadboard, or you're doing any little experiments at home building any circuits. But the most important question is, what does a resistor do? Well, it's really quite easy to demonstrate. And what we can do is we can just take a little test lamp and a battery, just a standard 9-volt battery, and of course we connect the bulb across the battery and it lights. We complete the circuit and the bulb lights up. Now, what will happen if we put a resistance in there? Now, I just happen to have a 56 ohm resistor here, which is, it's quite a low value, 56 ohm. Resistance can go up to millions of ohms, but 56 ohms is quite a small value. Now let's see what happens when we put the resistor in circuit with the bulb. See, the bulb is lighting, but it's nothing like as bright as it was before. The resistance is, the resistor is resisting the flow of current in the circuit. It's a bit like putting a kink in a hose pipe. So we just do that once again. If we go straight onto the bulb like that, let's get the resistor out of the way. If we go straight onto the bulb, see, it's quite bright. And if we go through the resistor, see, that resists the flow of current and the bulb is dimmer. And that's basically all that a resistor does. That's all you really need to know about how they function. But, of course, it gets more complicated. I get asked a lot about the resistor colour code and how it works. Now let's take these resistors here. These are 330R, that means they're 330 ohms. Now resistance is measured in ohms, and the symbol for ohms is that. It's the Greek letter omega, and you can either write it 330R or 330 ohms using this symbol. Now the colour code on here is orange, orange, brown, and that basically means 3, 3, and the brown means times by 10. So 33 times 10 is 330 ohms. Let's do another one. Now these resistors are marked 390k. That's 390 kilo ohms, or 390,000 ohms. Now their colour code, if you can see that, is orange, white, yellow. So that will mean orange, which is 3, white, which is 9, and yellow, which is times by 10,000, which gives you 390,000 ohms. And it's best to get one of these cards. If you buy a multi-pack of resistors, you'll get this card included, and it explains what all the colours mean, and they also explain that the third band of colour is the multiplier. You've also, at the end, you'll have a gold or a silver strip. Now, we don't really need to bother about that. That's a tolerance. That just means it's plus or minus 5% of the actual value. And that's really all you need to know about the basic function of a resistor. Now, what's a practical application of it? Well, if we take an LED, if we were to take a 9-volt battery and just connect it straight across the LED, we'd burn it out. So I've got a 330 ohm resistor in series with the anode here, and if we connect it up to the 9-volt battery, the LED lights up quite happily, because the resistor is restricting the flow of current to the LED. I think it's about 30 milliamps this one takes, and that's preventing the LED from burning out. Because LEDs, they only need a few milliamps to work, sort of 20, 30, 35 milliamps. So you must have a resistor in series with them. So that's a practical use for a resistor. Now, as I always mentioned, the resistors are measured in ohms, and that's how you spell it, O-H-M-S. Now, you have on foot, there's a bit of mathematics coming up, but it's not too difficult. You have to know Ohm's law. Now, I always remember it as V equals IR, which is voltage equals current times resistance. And a simple way of drawing it out is if you draw a triangle, you can go V equals IR, and just do that. And then you can look at it three ways. You can say that resistance is volts over amps, or you can say that amps is voltage over resistance, or V equals IR. And that's Ohm's law. Just remember V equals IR, and you can draw it out in a triangle, and if you know two of them, you can work out the current that's flowing in the circuit. Now, let's think of a very, very simple example. If you've got a battery, okay, and you've just got a resistor. Now that's the symbol for a resistor. That's the standard symbol that we use for a resistor in the UK. Now the old symbol, and the symbol which is still used in America, is that. So if you ever see that on a circuit diagram, that's a resistor as well. But anyway, going back to this circuit, if we have, say, a 5-volt power supply and, I don't know, a 10 ohm resistor, what's the current flowing in that circuit? Well, we can look up here and we can say that I equals V over R. So we can say that I equals 5 divided by 10, which equals 0.5. So we can say that in that circuit 0.5 amps is flowing, and that is basically Ohm's law. And that's all you need to know just to get yourself started. I should mention, going back to my little LED circuit, 330 ohms is just about the right value for lighting up the green LED. In fact, if you're ever uncertain about what value to use for an LED, always go for a resistor that's probably a bit higher, just to keep the current down. Because LEDs, light emitting diodes, they are quite sensitive to too much current, and you can blow them up very easily. I'll just mention light emitting diodes because, being a diode, it'll only let current pass in one direction. You notice if I put the battery on the other way around, it doesn't work. If I swap it around that way, it does. And that's really demonstrating the function of a diode. Now I'll just, while we're here, I'll just mention that. The symbol for a diode is that. And it's pretty self-explanatory really, because it's kind of an arrow and it's pointing that way. And it will only allow electricity to flow in one direction. And the symbol for a light emitting diode is that, which again is pretty self-explanatory, and you should have a resistor in front of it. And that will be the plus, and that will be the minus. And there's many types of diode, just as there's many types of resistor. But there's a nice little circuit. If you want to run a green LED off a 9-volt battery, use a 330 ohm resistor, and that'll be it. So that is all you need to know just to get yourself started. And I recommend, probably your best bet is, if you buy a pack of resistors off the internet, you can buy them really cheaply. Buy a bumper bag that's got loads of different values in. They're not particularly expensive, and you'll get one of these little charts with them, and you'll be able to work out the values. Just remember that the first two colours are the numbers, and the third colour is the multiplier. In fact, we can try it just one last time, because this seems to be the thing that people have the most trouble with. I've got this old resistor here. Like I say, this is an old resistor from the 1970s, and the colour code on here is red, violet, black. So if we look at that, that's 2, 7, and black is 0, so this is 27 ohms. And I should say that the resistor colour code is the same code has been used since the 1950s, so even if you're working on old radios from like 70 years ago, this resistor code still works. So there we go. That is a very, very quick and very basic introduction to resistors, and a little example of how to use them. And in the next video we'll be having a quick rough and ready look at what capacitors are and how they work. So I'll just leave you with Ohm's law there, and thanks for watching.